Hello and welcome to Mellow Labs. On today's episode, I want to make my boiler smart. Specifically, I want to be able to turn my heating on and off using my societally mandated personal spy device, and I want to do it in a renter-friendly way so that when it comes time to no longer live here, it's not a pain in the butt to remove. But first, let me explain to you how we currently turn the heating on and off, and for that, we have to go into the other room. This right here is my thermostat, and usually what you do is you set presets so that it turns on when you come in from work and whatever, but we literally never use that. We have the current temperature up here, and then we have the set temperature up here. And what we do when we want to turn the heating on is we just hold the plus button so that the set temperature goes above the current temperature, which causes this little fire emoji to show up, which tells the boiler to start warming things up. But this very fancy RF remote control doesn't actually talk directly to the boiler. It actually talks to this box right here. So what actually happens when you turn the temperature up on here is it sends a message to this box, which then turns on a relay, which means that to actually automate the heating in here, all we need is a remote control relay. And I can actually prove to you that it's that easy with a pair of pliers with an insulated handle. But don't do this at home because it's just for demonstrative purposes. If I bridge pad number 1 and number 2, it will turn the heating on. Just like that. And now that we know exactly how this works, I'm going to tell you how I plan to automate it right after this message from today's sponsor. Today's episode is brought to you by boot.dev. So here's a fun fact. I was contractually obligated to record myself using boot.dev, so I figured, okay, I'll do the Python course. I used to program a little bit in Python. Let's see how much I can remember. And the next thing I know, 2 hours have passed and I'm now a level 10. I got sucked in because it's actually fun and interesting. Boot.dev isn't like your typical coding coach. Instead, it's built a lot more like an RPG where you complete quests, earn XP, fight bosses, and level up, all whilst learning backend development in Python, SQL, and Go. Instead of just watching YouTube videos hoping that all the information sticks, you're hands-on programming and learning new things. And if for some reason you get stuck along the way on one of your quests, which I know you won't because you're very smart, there is an AI tutor called Boot who is a wizard bear who'll try to walk you to the right answer. He won't tell you the answer directly, but he'll point you in the right direction so that you can figure it out yourself. If you're still not quite sure, I recommend watching and reading their free online content, and when you are interested, get the paid membership, which unlocks hands-on coding and progress tracking. And if at some point you decide that it's not for you, there is a 30-day no questions asked refund policy. So head over to boot.dev and get 25% off your first year with my code MELLOWLABS. I'll also leave a link down in the description, so check it out. Thank you again to boot.dev for sponsoring this episode. Now let's talk about the plan. The boiler is connected to this thingy-majiggy with 4 wires. We've got live, neutral, 1 and 2, and these 2 are for the relay. So what I want to do is have a relay that I will splice in here and here, like so. I know what you're thinking. Wait, I thought you were going to remove this. No, this is staying because safety and landlords and things. I don't want to get rid of it. I want to keep it in the loop. It also has like a safety feature so that if the temperature ever goes down below 5 degrees, it will turn the heating on so the pipes don't freeze and stuff like that. So I don't really want to touch this. I'm just going to leave it alone and then just connect my stuff to it. So now my relay needs to be controlled by a microcontroller, and then the last thing we need is power, and I'm going to actually use the exact same kind of power supply thing that I used in my previous video, and let's hope it goes better than my previous video. They provide like 5 volts at like 200 milliamps. Again, it's going to be completely fine for this. Actually, no, it's like 700 milliamps. I double checked the data sheet after the video. It's like 500 to 700-ish. So plenty enough for this. So power supply, microcontroller, relay. And now if this is all you want to do, that's perfect. I actually want to add a couple temperature sensors. So I've got a couple things that are going to come off here and go to temperature sensor thingy-mabob. I'm actually going to have 2 of these, but you can daisy chain them, so we'll get into that later. And that is more or less plan there. So let's get to making it. So I went ahead and I collected up all of the components I need for this project. So let's begin with the relay. This is a 5 volt, 250 volt at 10 amp relay. It's important that the relay you get is suitable for the task you need it to perform. In my case, the relay that it's being not replacing but going next to is a 6 amp relay. So this being a 10 amp relay, it's perfectly suitable for the task we need it to do. It's powered by 5 volts and we can control it with just 1 volt, but we are using the ESP32, which is 3.3 volts, so we can very easily turn it on and off. For the ESP32, I'm using the C3 from DF Robot, which I got for free, which is why the price is so high. I would not pay this much for an ESP32. You can get the cheaper ones on AliExpress. They'll pretty much do exactly the same thing, but this uses a RISC-V processor with 160 megahertz, which means almost nothing to me. 4 megabytes of flash. Sure, I'm not writing code that's like that big. And the peak current draw is 335 milliamps, which is not nothing, but in the grand scheme of things, it's almost nothing. And that's also the peak. So like when it's at its most active, so sending out Wi-Fi signals and stuff like that. So not enough to bother the power supply that we're using in this. And speaking of the power supply, we are using the very cleverly named WX-DC12003. Who names these things? Anywho, it has an input voltage of 220 volts AC and an output of 5 volts DC at 700 milliamp hours. I got confused when I said milliamp hours previously because the 12 volt version of this can only do 200 milliamp hours, so 700 for the 5 volt one. And then for the actual temperature sensors, I'm using these. These are the DS18B20. These are like the waterproof version, so they're pretty good. They can be powered by 3.3 to 5 volts, and they can survive temperatures from minus 55C to plus 125C. They also use one wire bus, so each of these has their own embedded address, so you can daisy chain them. So you can connect both of these up to, I think, like 100 or even more, up to 1 GPI open and still get data from each sensor. So I'm going to use 1 GPI open for both of these, even though I don't really have to because this ESP32 has tons of exposed pins that I'm not really using, but I just want to play around with it, so I'm going to be using the 1. And for actually wiring everything, I have this beautiful diagram that you guys always ask me to make, but I never do because I'm lazy. So my live connection is going to go into the AC to DC converter, where it will be converted into 5 volts DC, which will then be split between the relay, the ESP32 and the temperature sensors. And then each of those has their own GPI open. So I've got GPI open 5 for the relay and GPI open 7 for the 2 temperature sensors. And then because this is well, the power connections on this are kind of messy. So before I continue, I'm going to make a little prototype PCB board to keep things nice and neat with connectors for the 2 temperature sensors and some breakouts for power in and for the relay. And hopefully that keeps the wiring headache of this down from what it usually is in my projects. Okay, that's what I'm going to do. Oh, also I'm going to make like a 3D printed enclosure for it, but we'll get to that when everything is wired up and connected and working. So let's do some wiring. Okay, so my soldering marathon is finally over. If you're wondering, it took about 2 episodes of The Good Doctor. Sean's about to be a dad. I'm very excited for him. But here's my circuit board. As you can see, the plan has changed slightly. I had a big enough prototype PCB board where everything fit onto it, and then I added some connectors, and I was like, yeah, it all fits onto the board. I'm just going to put it on the board. So I did, and then I did all the bits in between. I think everything is wired up correctly. I beeped things with my multimeter, and some things beeped like they were supposed to, and some things didn't beep also like they were supposed to. So I think I'm good to go and get some code involved. Now let's plug in our ESP32 into our computer using a reliable USB cable, and we're going to head over to the ESPHome web installer. And now we're going to click connect, select the port, connect, and we're going to click prepare for first use, which will basically prepare the ESP for the first use. And after that's done installing, we're going to set up the Wi-Fi, unless we get an error. Hamburger menu, configure Wi-Fi, same error. Let's try that a couple more times. Okay, maybe let's try disconnecting and connecting again and configure Wi-Fi. Same problem. One more time for good luck. Ah, it worked, fantastic. So now we just have to select our Wi-Fi name and type in our Wi-Fi password. Okay, and install. It looks like our device is now set up. So if we head over to Home Assistant and go to the ESPHome Builder, we now have a new device has been discovered. So let's click Show, and we're going to click Take Control, and it's going to ask us to give it a name. I'm going to call it Heating Controller, like so. And we're going to click Take Control. And now it's going to ask us to install a larger configuration. So we're going to click Install, and we just have to wait for it to compile and then install on the ESP32. So let's wait a little bit. Okay, so it looks like it compiled, uploaded, and now the ESP32 is connected to Wi-Fi and running. So we can click edit, and now we can start doing some programming. So first thing we want to do is tell it that we're using the one wire bus, and we're using the platform GPIO, and we need to tell it that we're using GPIO 7. And now we're going to tell it that we're using a sensor, which will be a temp sensor. And I'm going to give it a name like hot water temp with the ID hot water temp, and the update interval, I'm thinking about 10 seconds will be just fine. So now I'm going to copy this entire block and basically just copy and paste it, because we're basically doing the same thing for the other sensor. We are going to have to come back to this later because, well, we need to get the addresses of the individual temperature sensors, but otherwise it won't know which temperature to attribute to what name. So we'll come back to this later. And now I'm going to add a switch on the GPIO platform using GPIO 5 and give it the name like heating with the ID heating, and that should be all good to go. So let's upload wirelessly. And we've got a problem. Oh, I've defined sensor twice. Okay, my bad. If I go back and I just delete that, and we should be good. Upload. Yep, now it's compiling and uploading, so I'll be back when that's done. Okay, so it's compiled, uploaded, and running, and you can see we've got a couple of error messages because it doesn't know the addresses of the temperature sensors. So right above that, we have the one bus, and there's two addresses here. If we copy both of those and paste them into our editor, we can then go to the temperature sensor, and right under the name, we're just going to add address, and we're going to paste in one of those, and then we're going to do exactly the same thing for the other one, and paste in the other one, and then get rid of them from here. And again, let's save and upload wirelessly. And now when this is uploaded and compiled, we should have the names and the temperatures for both of the sensors. So let's wait for that. And yep, there we go. It's working beautifully. I don't know which sensor is which, so I'm just going to hold on to this one and figure out which one that is. I'm going to rub it a little so that the temperature goes up. And when I see it go up, okay, that's the radiator one. So I'm going to grab a pen and just quickly write R on this connector so I know that that is for the radiator temperatures. Now we can go into Home Assistant settings, device and services, ESPHome, and we've got the device here. We can click add. It's going to ask us what room we want it to be in. I'm just going to select home, and we now have the two temperatures and also the relay switch. So I can click that on and off, and hear that my relay is actually clicking on and off. So that all works perfectly. So now we just need to design a little case for it. I think Fusion just updated. I finished modeling the box, I turned it off, went downstairs, made myself a beverage, came back up, opened Fusion, and it's in dark mode now. I'm gonna have to sift through the settings later to change whatever it changed, but it doesn't matter. For some reason, some of you have convinced themselves that I am some kind of good designer and I am an authority. I am most definitely not. I am a horrible designer. I have no idea what I'm doing. I am the equivalent of just like throwing clay at a spin thing and just kind of poking it. I don't know, I just kind of measure and pull and push things. That's all I do. And that's exactly what I did here. So if I open up, this is the 3D model of the circuit board I made so that I can have a rough estimation of like how big it is and what I can do with it. So around that, I then designed a box. Let me get rid of the lid. Hopefully the circuit board should just slide in here so that I don't actually have to put screws or anything in there to hold it in place. And then the lid will go in front of it and just kind of press fit into the box and hopefully hold the circuit board in place, and it has a hole for the wires to come out of. And that's kind of it. I am not a good designer. I don't even know if this is gonna print properly or if my circuit board is going to fit inside of it. I have no idea. I just kind of guesstimated. So I'm gonna send this off to my 3D printer, and whilst this is printing, I need to make a couple cables that I can actually like plug into this. So let's start this print and then do that.
It's printing.
Okay, so to connect this circuit board to the rest of the system, I'm going to need some cable. I'm not sure where I got this one, but it still has a plug on the end, and apparently it's rated for 10 amps, so should be plenty good for this. I'm gonna give myself about 25 centimeters of this cable, and I'm gonna do 2 of these, so let me cut this down to size. Now I want to connect this end to the circuit board here, but I don't want to just remove the insulation and just put the wires in there. I'm actually going to put some of these crimps on it so that it's kept nice and neat. So let's take the insulation off and crimp some of these on. Usually when you get these, they also come with this like crimping tool. So all you have to do is put one of these guys on here and then just put it in the crimp, and that's it. And now these should pretty easily just fit in here. Perfect. I'm not going to tighten them down yet because I need to do the other end. So on the other end, I actually need some of these like fork connectors. So let's do those. And specifically with these, I don't know if I just don't have the right tool for these or if these are just really cheap. These sleeves on here don't actually work the way they're supposed to. First of all, they don't actually fit into my pliers. And then when I crush them, they don't actually like shrink down to protect the thing. They kind of just fall off the cable. So what I do is I just cut these off, and I just put on some heat shrink tubing. So let me grab 4 of these and remove that plastic from all of them. So because these ones don't fit into the crimping tool with the same way the other ones do, instead I just use pliers to just squish them on. And you want to make sure that they kind of overlap. So this goes under, and then you can squeeze them on the side like so. And that should be good enough. And again, the heat shrink tubing goes on there to protect it. So let me do all the other ones now. I'm going to use my heat gun to shrink the tubing. It sounds like my print just broke. Well, let me finish this. Okay, fantastic. So the 2 cables are done, the circuit board's done. Now I just need the 3D printed case and we can install it. So let me go check if that actually broke. Good news, it didn't actually break. It just finished printing at the perfect time. So let's see if the circuit board actually fits in here. It's giving too tight. On this side, I got the clearance perfect. On this side, it's like a tiny bit off, so it just pushes this connector forwards. I'm gonna see if I can just trim this down a little bit so I don't have to reprint the whole thing. Okay, that fits in pretty well. It is a little bit tight because I can see the, well, this connector is being pushed slightly that way, but I think that's honestly gonna be just fine. And let's put the lid on, and that fits on perfectly. Okay, let me attach the wires and then we can go and install it. Brown is live because that's the color your pants go when you touch it. And the other side does not matter. Let's get these 2 cables in through the cover, like so. and get the temperature connectors in here as well. This one's got a marking, so this one goes to this one, and this one goes to this one. Push that in there, and the cover. Oh, perfect. Can't get my fingers in there, so I'm not gonna get zapped. I did consider modeling in some screw mounts to this so I can actually like attach it to the wall, but because I want it to be renter friendly, instead I'm just gonna use a command strip. Okay, so all that leaves us with is installation. So I'll see you downstairs. Okay, so before I start installing anything, first thing I'm gonna do is turn the boiler off, like so. And second, I'm going to, oh boy is this messy. I should probably vacuum in here. Second, I'm going to turn that off, which yes, it does also turn that off. So we can now take this off and install our thing. I'm gonna install it at the back here where it's not particularly visible and just run the wires through the existing hole over here, like so. And this is my power wires and that's for the relay. So I'm just gonna connect them in here. Why the hell did I grab the flathead screwdriver? Okay, and now hopefully that doesn't get in the way of me putting my box back on. And it doesn't. Fantastic. I feel like I probably should have tested this before actually plugging it in here, because I'm basically just testing this in production now. So YOLO. The power supply LED is on, so that's very positive. The ESP is blinking, and ooh, it seems to have connected. I've got Home Assistant opened up. It works. Cool. So now I'm gonna turn the boiler on, and it's gonna have to do its setup process for like a couple minutes. The boiler is all set up, so the last things I need to do before continuing is attaching the temperature sensors. I just don't quite know where exactly I need to attach them, so I'm gonna run the hot water, and then whichever pipe gets hot gets the hot water temperature sensor. Yeah, this one is definitely the hottest, so I'm pretty confident in calling that the hot water pipe. Now I'm gonna use some zip ties to attach the temperature sensor. I know for a fact that this isn't gonna give me the best heat transfer, but I'm not really adding these in here for any particular reason. It's kind of just to play around and see what's happening in the system. And now for the radiator temperature, I'm just gonna turn the heating on. And it works. And we just have to wait for it to heat up and pump some water through before I can figure out which pipe it is. I think it's this one. Okay, it actually feels like it's this one more than any of the other ones, so I'm gonna put the temperature sensor right there. All is connected. I've got hot water temperature and radiator temperature. Obviously I need to wait for the sensors to like acclimate and all that, but we should be good. Okay, so that all looks good and it seems to be working, so I'm happy. Now I know this isn't the best way of actually automating household heating because all I'm doing is putting the boiler on and off. I still have to walk around and turn on each of the radiators I actually want to use. Now I do plan to automate them in the future. I just don't know if I'm gonna go the DIY route or just buy an off-the-shelf solution that's gonna work. If you have any thoughts, do let me know down below. And I guess that's it for this episode. So thank you very much for watching. Thank you very much to boot.dev for sponsoring this episode, and I'll see you in the next one. Goodbye. Oh. Ah.